Ever wondered why you're not floating off into space right now? Well, the answer lies in the enigma of a force that invisibly tethers us to the ground. This force, my friends, is none other than gravity. Gravity, in its simplest form, is a force that pulls everything towards the center of the Earth. Imagine dropping a ball. It doesn't fly off into the sky, but instead, it falls to the ground. That's gravity at work, pulling the ball towards the Earth's center. But gravity isn't just an earthly phenomenon. It's a universal law that governs the movement of all celestial bodies, from the smallest asteroids to the most massive stars, and everything in between. In the grand cosmic theater, gravity is the director, dictating how celestial bodies move and interact. It's the reason the moon orbits the Earth and why Earth, along with its fellow planets, circles the sun. Even beyond our solar system, gravity choreographs the dance of galaxies, driving the expansion of the universe itself. Now you might be wondering, how does this seemingly invisible force work? At the heart of it is a principle proposed by Sir Isaac Newton over 3 centuries ago. He suggested that every object in the universe attracts every other object with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This principle, known as Newton's law of universal gravitation, provides the basis for our understanding of gravity. But gravity isn't just about keeping things in their place. It plays a significant role in shaping the universe and its phenomena. From the formation of planets and stars to the paths of comets and asteroids, gravity leaves its mark on every aspect of our cosmic neighborhood. So, the next time you feel the solid ground beneath your feet or gaze up at the night sky, remember the invisible force that keeps everything in check. Gravity, this mysterious, ubiquitous force, is what keeps us grounded and maintains the harmony of our solar system. Now, isn't it intriguing how this invisible force keeps us grounded and the solar system in harmony? Imagine the solar system as a grand cosmic ballet, with each planet gracefully twirling on its path. But who's the choreographer? Gravity, the ever-present yet invisible force, is the grand maestro that dictates the celestial dance of our solar system. It is the silent puppeteer that pulls the strings, ensuring each planet stays on its predestined path around the sun. Gravity is an interesting force. It's both incredibly simple and yet infinitely complex. At its core, gravity is a force of attraction that exists between any two masses, any two bodies, any two particles. It's what keeps our feet on the ground and what makes an apple fall from a tree. But when you scale it up to the level of the solar system, it becomes a grand ballet of celestial bodies. Let's take our sun, the star of our cosmic ballet. It's over 1 million times larger than Earth and holds more than 99% of the solar system's total mass. This immense mass gives it an incredibly strong gravitational pull, acting like an anchor, keeping all the planets in their orbits. Each planet follows a path around the sun known as an orbit, a route carefully choreographed by gravity. The closer planets are to the sun, the stronger the sun's gravitational pull on them and the faster they travel. That's why Mercury, the closest planet to the sun, whizzes around it in a mere 88 Earth days. Meanwhile, Neptune, the furthest planet, takes a languid 165 Earth years to complete its orbit. Yet, despite the sun's immense gravitational pull, the planets don't fall into the sun. That's because they're also moving sideways, essentially falling around the sun. This delicate balance between the sun's gravitational pull and the planet's sideways motion is what keeps the planets in their orbits. Without gravity, there would be no solar system as we know it. It is the director of the cosmic ballet. This invisible force is responsible for the grand dance of the planets, turning the solar system into a beautifully orchestrated cosmic ballet. Imagine gravity as invisible strings connecting every object in the universe. How does this play out in the solar system? Well, let's delve into this fascinating concept. These invisible strings or gravitational forces are at work all around us, even though we can't see them. They pull and tug at everything, from the smallest dust particle to the largest star. In the solar system, these strings are especially important. They bind the planets to the sun, keeping them from hurtling off into the vast void of space. Let's take a closer look at our own planet, Earth. It's not just the sun that has a gravitational pull on us. Our moon, though much smaller than the sun, also exerts a gravitational force on Earth. This is most evident in the tides. When the moon is closest to a particular part of the Earth, its gravitational pull causes the water in the oceans to bulge out a bit, creating a high tide. And when it's farthest away, we get a low tide. Isn't that fascinating? But here's something even more intriguing. As the distance between two celestial bodies increases, the gravitational pull decreases. This is why, despite the sun's massive size, its gravitational pull on the outer planets is less than on the inner ones. It's all about distance. This might make you wonder, why don't the planets just keep moving farther and farther away from the sun, escaping its gravitational pull entirely? Well, that's because of the delicate balance between the planet's forward motion, or inertia, and the sun's gravitational pull. The planets are constantly falling towards the sun, but also moving forward fast enough to keep missing it. This creates an orbit. So, you see, gravity is like a cosmic puppeteer. It pulls the strings of the celestial bodies, guiding their movements and interactions. It's this constant dance, this intricate ballet of celestial bodies that makes our solar system, and indeed, our universe, so mesmerizing. Gravity, the invisible puppeteer, pulls the strings of the celestial bodies, creating a beautiful cosmic puppet show. Is gravity the same everywhere in the solar system? A question that might seem simple, but the answer is as complex as the cosmos we inhabit. Let's delve into the gravitational nuances of our solar system, shall we? Gravity, you see, is not a one-size-fits-all phenomenon. It's an intricate dance of mass and distance. The force of gravity varies across the solar system, depending on the mass of the celestial body and the distance from its center. It's like a cosmic game of tug-of-war, where the heaviest planets pull the hardest and those farthest away pull the least. Take Earth, for instance. It's our home base, our point of reference. The force of gravity here is what we consider normal. But venture out into the cosmos, and normal takes on a whole new meaning. Consider our moon. If you were to hop on a lunar lander and touch down on its cratered surface, you'd weigh a mere sixth of your earthly weight. Why? Because the moon's mass is only a fraction of Earth's, and hence its gravitational pull is considerably weaker. Now, imagine you're on Jupiter, the behemoth of our solar system. Despite being more than 5 times farther from the sun than Earth, the gas giant's immense mass creates a gravitational force 2.5 times that of Earth. You'd weigh more than twice what you do here. And let's not forget about the dwarf planet Pluto, way out in the solar system's frosty fringes. Despite its distance from the sun, its gravity is about a sixth of Earth's, similar to the moon. So your weight on Pluto would be roughly the same as on the moon. In the grand cosmic ballet, each celestial body has its unique gravitational rhythm, choreographed by its mass and distance from the center. It's this interplay of forces that keeps the planets in their orbits, the moons in their paths, and the solar system in harmony. In the vastness of the solar system, gravity dictates the weight of your world. So, the next time you step on a scale, remember, in the cosmic perspective, your weight is not a constant, but a variable subject to the whims of gravity. What would happen if gravity suddenly disappeared? This question might seem like the stuff of science fiction, but it offers an intriguing thought experiment that underscores the pivotal role of gravity in our solar system. Imagine, if you will, a universe where gravity simply ceases to exist. This fundamental force, the invisible hand that shapes the cosmos, vanishes in an instant. The immediate consequence? Utter chaos. Our solar system, a harmonious union of celestial bodies, would rapidly descend into disarray. Planets, once tethered to the sun by gravity's unyielding grip, would be set adrift, careening off into the vast expanse of space. The Earth, our home, would join this cosmic exodus, its inhabitants suddenly finding themselves in a weightless world. Asteroids too would be set loose, their once predictable orbits now a thing of the past. These rogue rocks, untethered and unpredictable, could pose a significant threat to any celestial body unfortunate enough to cross their path. Even the sun itself would not be immune to gravity's absence. The immense pressure at its core, no longer counterbalanced by gravity, could trigger a catastrophic explosion, scattering its matter across the cosmos. These dramatic scenarios underscore the crucial role of gravity in maintaining the structure and order of our solar system. It is gravity that keeps the planets in their orbits, ensuring the Earth's steady journey around the sun that gives us our seasons. It is gravity that tames the wild dance of asteroids, confining them to predictable paths. And it is gravity that holds the sun together, enabling it to shine brightly as the heart of our solar system. So, while it's fascinating to imagine a universe without gravity, it's clear that this force is far more than a scientific curiosity. It is the cosmic glue that holds our solar system together, a silent symphony that orchestrates the dance of celestial bodies across the cosmos. In the grand cosmic orchestra, gravity plays the pivotal role of the conductor, ensuring that every note is in perfect harmony.